Morning, Yasmina, and thanks a lot. And good morning, everyone. Happy New Year. I'm up here in Canada, so I apologize for the polar vortex we seem to have sent farther south. And looking at the chat, it looks like people are coming from all over the world for this topic, including some of our speakers. I'm really, really happy that we're able to put on topics like this one. It's something that I think doesn't get talked about enough, and several of the people you'll be hearing from today have presented work in the past on the ways in which data and ubiquitous connectivity and new interfaces for collecting and displaying information can help us do a better job enforcing criminal justice, balancing ethics and transparency, and also identifying and hopefully avoiding conflicts in the first place and sort of mitigating disasters when they do happen. So we have a fantastic lineup of people today. I couldn't be happier at the list of folks that we've managed to get here to speak to us. We've got Ari Gesher from Palantir Technologies, Jeannie Stamberger from Resilient Africa Network. Jason is joining us from evidence.com, looking at how police officers are able to record information. Marie and Chris from the International Peace Institute. Helena from Interpeace, talking about how to use big data to sort of rethink the early warning around conflicts. Linus from the Flowminder Foundation, talking about how to measure mobile phone data to understand how populations move around during and after disasters. So I'm really thrilled for the lineup here. Thanks in advance to all the speakers for joining us. And I'm going to hand things over to our first speaker today, Ari Gesher. Ari?
Thanks, Alistair. Good morning, everyone. Really happy to be here. My name is Ari Gesher, and I work for a company called Palantir Technologies. Today I want to take a sort of a deep dive into a look at how you can use data, what kind of techniques can be used to solve these kinds of problems out in the world that necessarily include people on the other side of the problem, causing the problem, trying to avoid detection, and really sort of changing the nature of the problem from most data problems. So the place that I want to start is actually back in 1997. Before 1997, it was a lot of fun for computer scientists to build systems to try to beat humans at chess. And in 1997, Deep Blue beats Kasparov, and suddenly the world says, well, we need a brand new sport. That's not that much fun anymore. We've settled that question. And so the new sport that they come up with is something called freestyle chess. And freestyle chess is an interesting form of a chess tournament in that there are no rules other than play your moves, right? So you can put together any kind of team that you'd like. You could get a team of psychics together to decide what to do. You can enter Deep Blue into the tournament. But most importantly, you can actually come up with hybrid teams of humans and computers working together in concert. And so freestyle chess ends up being this really interesting laboratory to study the effectiveness of different kinds of systems and different approaches. In 2005, there was a freestyle tournament, and Kasparov actually wrote about this pretty extensively, as has Tyler Cowen, the economist, where a new type of chess-playing computer named Hydra was entered into the tournament to play, sort of like Deep Blue, but more powerful networked FPGAs. And the makers put together the tournament to see whether or not it could win. And the results of the tournament actually surprised a lot of people. So the surprising thing wasn't actually that Hydra lost. Hydra was knocked out fairly early by a grandmaster using a laptop in sort of a commodity chess program. So much less computing power, but an expert human. The really surprising result was that the winner of the tournament was actually a team of two chess amateurs. They knew enough to play the game, but they weren't particularly good at sort of beating other humans, who had put together a little bit of custom software to tie together 3 or 4 different pieces of software running on commodity hardware. And so in writing about this, it wasn't that the strong machine lost or that the strong human using a weak machine beat that strong machine. It was that a weak human using similar levels of computing power, just sort of commodity hardware, but able to interface with that software very, very strongly, we were able to beat some of the best people in the world at chess, even those that were aided by computers. And so the sort of the magic existed in that interface and that ability for the human and the computer to work together in concert. We can contrast this with sort of a really dominant idea that has existed in computer science for the better part of 60 years. Right? In 1957, the idea of AI is introduced to the world, and it kind of becomes the holy grail of computer science. How do we build thinking machines? And in this pursuit, much of the techniques that we use today in the field of what we'd call big data or machine learning, all of that comes from this sort of search for AI. But the simple truth about all of these techniques is that they're based on statistics, right? They're based on sort of a simple pattern of gather a lot of data about the phenomenon that you wish to study, train it into a statistical model, and then use that trained up model to characterize future instances of data that you want to classify and make decisions about. Now, this works fantastically if what you're trying to do is recommend products to people. If what you're trying to do is figure out if your customers, to reference sort of a famous story, figure out if your customers maybe have changed their purchasing behavior in such a way that maybe now they're pregnant, and so you can market to them in a whole new segment. The place where it fails is where you have an adaptive adversary, right? And this is sort of actually well known even among the theorists in machine learning, that these statistical techniques, if the nature of the data is changing over time, or in a lot of cases when you're dealing with things like criminal justice or global conflict, you actually have incomplete data, either one, if you can't build up this good statistical model, then these techniques don't work, right? And you actually find this in all of these domains where the folks on the other side, the humans on the other side, as soon as they know that they're being detected, as soon as they know that you can see them, they'll change their tactics, right? And this applies across many, many different domains. Sort of one that's in the news a lot these days is cybersecurity. Criminality of all sorts, especially sort of financial crimes, is a place where a lot of data comes in. This is a credit card scanner that you can sort of glue to the front of an ATM to steal credit card numbers or ATM numbers. Before I started working at Palantir, I didn't realize just how big the world of fraud was. So that you can defraud the government, as you do in a case like this. You can defraud other people. You have institutions defrauding each other, and it even comes to play in things like networks of human trafficking and sexual slavery, and of course all types of criminality, including things like terrorism. So if these classic approaches don't work, what is the right approach to take here? What does work? Well, if we go back to the birth of AI, to the early days of digital computing, there were two sort of titans of the field who really took a very different tack about how to solve these problems. So on the left here, you see Vannevar Bush. Vannevar Bush ran the Manhattan Project during the war. He ran something called NACA, which later became NASA, and he chaired what was the precursor of the National Science Foundation in the United States. On the right is Jared Licklider. He was the first head of DARPA. He's known as the Johnny Appleseed of computer science. Came up with all kinds of ideas, and ran something called Project Mac at MIT, which later became sort of the thing that birthed Unix to the world. So both of these guys, when writing about how they thought digital computers were going to change the world, were not the biggest fans of AI, and instead they really, hung their hat on something called intelligence augmentation, and that was all about building systems to create a really good division of labor between the humans and the computers, where computers do the things that they're best at, and the humans sort of still do things like hypothesis formulation, a lot of the pattern matching, where the computers do retrieval and statistical correlation, and all the things that we know the computers can do very fast and error-free. So if you're interested, I'd actually suggest looking these guys up. Vannevar Bush wrote something called a piece called As We May Think that was published in 1945. It sort of explains the world today, 60 years ahead of its time. And Licklider put out a paper in 1960 called Man-Computer Symbiosis. It's a short read, but it really sort of lays out the whole argument about this. So I work at a place called Palantir, and we've really taken this notion of human-computer symbiosis to heart, and it's really the overarching design aesthetic that we use to build our systems. So we build systems that always have a human in the loop to make decisions. To a human, it maybe looks something like this. This is a prototype of one of our newer web interfaces with some sample data from the Iraq War. And you can see many examples of our interfaces, actually, if you go to our website. But the interface is a really important piece. But at the core of what's going on is what I would call a projection, right? And so sort of like the notion of a mathematical projection from one coordinate system to another. If you think about the way that most data systems work in the world, the way in which they withhold, represent information even to the user is for the convenience of the computer. It's about how the data storage system represents and manipulates that information. I'm talking about things like database tables, spreadsheets. Nowhere in those systems does the real world that data represent emerge. And in fact, if you want to go talk to those systems, you have to be fluent as a human in the way in which the computer represents and manipulates that data. So we build systems that actually turn this on its head, and we say, let's take all the different data that's available about a problem that an organization may have, fuse it together into a human conceptual model, and sort of pull the different fragments from different places and represent it to the person, to the analyst, in a form that they can fully understand so they can leverage the power of the computer. And so we have an object model. There's a lot more about this on our website that you can go look up. The idea being that everything coalesces into virtual objects, right? These virtual objects represent the same phenomena in the real world that a person would expect when thinking about the problem, and we coalesce all the different fragments from the different data sources into this object model and then build an interface on top of it. So, and this is applicable across many different things that don't have anything to do with conflict or with criminality or anything like that, things like pharmaceutical research. But in the sense where we're in the case where we're dealing with an adaptive adversary, you can think of our approach as taking sort of a very simple, here's a high-level recipe for this, right? And the idea is that you fuse the data into this human conceptual model. You present a familiar, interactive, and expressive user interface where familiarity is actually all about making sure the analyst sees the problem in the interface that they're presented rather than having to do some level of indirection or composition in their mind. The interface needs to be interactive in that when dealing with an adaptive adversary, you need to be able to spot the shift of patterns over time. You need to be able to ask a question that you don't know that you need to ask until you see the answer to the previous one, so supporting ad hoc analysis. And when we talk about an expressive user interface, it's actually all about being able to compactly represent to the computer the work that you want to do. So if I say, show me all the burglaries that have happened within a 5-mile radius of this point in the past 2 years, that's an easy thing for me to formulate. If it takes me 120 discrete commands to enter into the computer to express that, that's problematic, right? It's error-prone. I'm less likely to do it, and it really sort of slows down the speed of my analysis. Finally, we do actually bring algorithmic analysis into this, but we always use it to augment and filter rather than to make decisions. Because when you're dealing with an adaptive adversary, algorithmic decision-making just doesn't really work. But you can use sort of the power of the computer to flag things that are interesting, to look for simple patterns that then need further inspection by humans. And this becomes really important in the modern data context. When you have huge, huge volumes of data, there's no way for people to move through all of it. And if the algorithms can't make decisions, what you need them for is to filter it down to an interesting set that humans can actually look at. So I want to go through a couple examples. And the first one, I really want to just point out the scale and scope of things. This is online bank fraud, right? Pretty simple to think through, right? The idea here is that you compromise login credentials to an online bank. You get someone's sort of username and password. You log in and you look for users that have home equity lines of credit as they're poorly watched. They're credit lines that have a lot of money in them, but people tend not to pay attention to them if they're not actively using them. You move money in a set of small transactions to a network of accounts so it becomes difficult to trace, and then eventually you wire the money out of the bank in a way that gets it out of that jurisdiction, and then you do whatever you're going to do with it. We've worked with customers on this particular problem, and what we've seen, for example, with one customer was a situation where they were creating literally 0.5 terabyte a day of web server logs, about 100 gigabytes a day of transaction data inside the bank. And we needed to really join this data across these business lines because you might see money moving from a personal checking account to a business checking account, and those are two different systems in the bank. And in fact, sometimes even the same type of account will be in a different silo because of things like mergers or legacy systems. So we join all the data there. We use automation to flag things that look suspicious with really simple rules, like did someone log into this account from Nigeria? It turns out to be a really useful one. And then human analysts actually make the final determination by looking at these network accounts, whether or not it's fraudulent. So that's a really quick example. One I want to go a little bit deeper on is something called credit card bust-out fraud. Now, this is a very different kind of fraud than we're used to thinking about in terms of credit cards, it's not, you don't steal people's legitimate credit card accounts. Instead, you make up fake people and create new accounts. And so this makes it very difficult to find. Sort of simple credit card fraud where your card is used for something anomalous, you actually can't solve that one with automation, and most places do. A lot of us have gotten that phone call. Sometimes it's even automated. Did you, just buy something in Barcelona even though you're in California? No, I did not. But bust out's very different. So here's a recipe for how you do bust out. So you open up a bunch of accounts under fake identities. You actually use the accounts. You buy things to drive the credit line. You hit some magic number when your credit line, hit that high watermark you're interested in, and then you max out all the cards in one day. If you're really crafty, then you write fake checks to zero out the balances because they'll zero your balance before they clear the check. Then you max out the cards a second time, and then your identities disappear. And then if you're making a career out of this, you start over at step one. So this is a really difficult thing to track down and to find. And what we did in working with the customer on this was to really integrate all the data about the account, take a full sort of 360-degree view of this. So it's not just the account details of who's opening the account. It's also caller ID data about who's calling into the bank. It's web server data about who's logging in to the online interface to check the accounts or make payments. It's the transaction records about how the accounts are used, and the payment data about how these payments are being made. What accounts are being used, what sort of type of payment, like a money order. And once that's come through, we can then actually apply automation to it to cluster it across all these different dimensions. So it's everything from where and when the cards are being used, or seemingly unrelated accounts being used at the same store within a minute of each other or something like that, are unrelated accounts being accessed from the same IP, caller ID data, all these things, looking for ways to join accounts that don't seem to be actually related with a real surface examination. And so that clustering then leads to the clusters can be scored based on the aggregate credit risk. That aggregate credit risk tells you, how important it is to look at it, and then you queue it up for human analysis. And the humans actually can sort of pick apart these clusters to decide whether or not there's something funny going on. And false positives ends up being a real issue here. One of our customers ran into a situation where they found one of these clusters that had $20 million of aggregate credit risk, and they went, wow, we found the mother lode of credit card bust-out fraud. When they started picking it apart in the interface, which, just to give you a quick screenshot, looks something like this, they found there was a single linking parameter that brought all these accounts together, right? And that single linking parameter was a phone number, a caller ID data that people were using to call into the bank. It turns out when they looked up what that phone number was, it was the outgoing line from a very large company that had something like 100,000 employees. And so statistically, some number of them banked at the bank. Some of them, would even default on their accounts. And so, of course, they didn't shut down these hundreds of accounts that they found, which would have made for some very angry customers. So the results of a system like this, it was actually 20 times more effective than a previous solution. Really, really sort of blew it out of the water by reducing the amount of time that analysts had to spend on this. And it returned 1,000% ROI over 4 years to the bank in question, which sort of really makes it worthwhile to do. Now, an area that we see really heating up around this is actually network defense. And normally I'd go into a much longer demo, but we're a little tight on time today. So instead, here's a link that you can actually take. It'll take you directly to our website and a demo that actually shows the interactive analysis with integration of data across a network to sort of be able to track what we would call APT, advanced persistent threat, basically hackers breaking into your network and sort of lying in wait to get at those really critical systems. And so that's what I have today. I'd like to yield the rest of my time to any questions that we may have. But the thought I want to leave you with is that adaptive adversaries, of course, aren't going away. This is like the world is filled with humans who disagree on what should happen. And this is kind of the right approach to take to shut it down.
All right, cool. Thanks, Ari. Interesting overview. A couple of questions for you. First of all, what's the conviction rate for these kinds of crimes? Maybe you can talk a little about how this data is used as part of the conviction and some of the evidentiary requirements too.
That's an interesting question. I don't have hard numbers for you. I know one of the places where were being used is actually to deal with sort of data in large lawsuits, which is a whole other realm for this. I do know that the bank is less concerned about in the fraud case. The banks are less concerned about the conviction rate and more concerned about actually holding on to their funds. And there, at least in that first example, the online fraud example, I believe that the number that I saw was a 75% reduction in fraud in actually the money leaving the bank, which is really sort of the important thing there. In terms of conviction rate, the thing is that detecting and stopping fraud can sometimes be easier than actually bringing the people to justice. Like if they're operating in a completely different jurisdiction, you may not be able to collect enough evidence to stop them, or to figure out who they are, rather, but just enough evidence to stop the crime from happening, which is sort of very different than the criminal justice perspective.
Okay. A question here from Craig Richardson. I'll read it verbatim so I get the words right. What role do you see for private sector companies like Palantir in collecting data rather than just providing tools for U.S. agencies to process and enhance legally gathered data?
Yeah, that's a really great question. Palantir as a company doesn't do any data collection whatsoever. We don't build any data collection technology. We very simply build data analysis software. So our base assumption is that data is out in the world. People have data and they want to do stuff with it. What we do recognize is that a lot of the data that can be handled, especially by governments in law enforcement or national security context, can be very sensitive and have a lot of privacy issues around it. And we spend a lot of time building features into our software that enable things like privacy protection so that you don't have to give your analysts access to all the data that you may have collected or have gotten to. And so that's sort of from our perspective. And I actually don't know a lot about data collection that's happening sort of by private companies specifically doing that, other than what we all know about in terms of places that sort of the big companies like Google and Facebook, which collect data for their own purposes that the government can get access to. And that's a really important policy question about how that really is kind of defining our era, and it's a really fantastic public debate that's going on around this. We do see a need to really think about building architectures for privacy. And in fact, I'll throw in a little plug here. We have a privacy and civil liberties team that thinks really hard about these features and how to apply them to different data sets. And we're currently working on a book through O'Reilly to sort of outline how to build systems that do as much to preserve the privacy when handling this kind of sensitive data, to put as much oversight and responsibility and restricted access on it as possible, so that even places like law enforcement or national security agencies that do have a job to do can do so without sort of violating people's privacy in a mass sort of way, to do much more targeted work and work that can have oversight to make sure that they're only keeping a scope as narrow as they possibly can to do the things that they're supposed to do. All
right. We got a bunch of other questions here. I'll let you answer some of them in chat, but I want to stay on schedule here. So if you want to switch over to chat and join people there, there's 3 or 4 questions for you in that. Our next speaker, Jeannie Staberger, informs me that the title on her slide is wrong. She is, among other things, an adjunct lecturer at Tulane University and working on top secret, really cool stuff that she can't tell us about yet. She does, however, have a tremendous amount of real-world experience trying to deal with managing disasters and maintaining connectivity and understanding how those disasters work together. So, Jeannie, welcome to the conference.
Thanks very much, Alistair, and thanks very much for inviting me to join. And I just want to clarify that my background is more academic. I don't have professional disaster management experience, but I've worked with lots of different professionals, private sector companies, academic researchers, government agencies over the last many years. And so this will kind of be a download from a big data point of view on what disasters can kind of tell us. And the perspective that I'd like to take on this for this wider audience and this wider talk that we've got going on is that disasters are really an excellent test bed for physical hardware and software, and how they work together, especially to pull out data when systems are challenged. And really I look at disasters as an extreme test bed for working across high and low tech to make sure that you can access your data. You can do analytics, you can do decision making in worst case scenarios. So typically the software we work with is not really tested for robust scenarios like this. And following on Ari's talk about cyber security, one of the biggest concerns that, for example, people who think about this a lot, such as at the Naval Postgraduate, are worried about when we talk about natural disasters is not necessarily the disaster itself, but a cyber attack on top of natural disasters. So it's this combination of systems disrupted because of physical problems and then adding the internet, the connectivity, and all of the data and security issues that we've got on top of it. Imagine a compromised situation. And so we're going to talk a little bit more. This is a U.S.-centric talk. I've worked internationally, but mostly what we're going to talk about is how professionals in the United States are working with data. And we're really going to, what I'm going to focus on here is mostly the specific goal of a coordinated response. So there are lots of goals that different agencies have during disasters. We're going to talk about how you get all these different people that are involved in a response, from military, police, fire, emergency managers working at the city, county, federal level, nonprofits, faith-based organizations, volunteers, survivors. All of these people are involved in the response, and coordination is a big challenge, and data fits right into that because it's how you get the right information to the right people and really making it understood in the right context to advance forward. So I'm going to talk about what has changed recently, specifically about what data are available now that haven't been available before, and then the challenges. And these challenges are really multifaceted. And there are lots of software programs out there that kind of holistically solve a lot of the problems. But what I'm going to talk about is how things are really happening on the ground in most recent disasters. And we'll get into that deeper. There are a lot of challenges from sociological, technological, data processing, and so on and so forth. And I'll show you a few current coordination mechanisms, and then we can talk about some questions. So as I mentioned, there are lots of actors to coordinate. So you've got emergency managers, police, fire, corporations. How corporations interact with a professional response is really an interesting and important problem, especially when you talk about cybersecurity. Nonprofits, faith-based organizations, volunteers, and survivors. So as you can see from this list, there are lots of different people with lots of different understandings about data. They may have really different responsibilities, different goals, and a very different sensitivity to how information is authenticated. And we'll get into that a little differently. This is a picture of an exercise, and you've got the military coordinating with other agencies here. This is a small slice, and this image is very similar to what you see, for example, when the UN uses their cluster system to go into a response. Face-to-face interactions of different agencies in a hierarchical system. However, with connectivity, we can do a lot more. We can add other actors in. It presented a whole number of additional challenges. So let's talk about what has changed. What did it used to look like? And this is a fantastic photo from 1936 of ham radio contact. And ham radio is really one of the best ways to get connectivity, to talk to other people in a disaster. And that's what was happening then. This is an example of, this is the AT&T GSOC, their Global Security Operations Center, and it looks very much like a movie, right? You've got a lot of screens, you've got a lot of cool-looking things. It really looks like we've gone from ham radio to something where there's a lot more data and available and a lot easier access to it. However, what we really want to talk about is what is actually happening in a disaster on the ground with professional response. So there are a lot of data types that are on the rise. More data are available. There's, of course, satellite. Ground reports will, of course, encompass social media. And historic data is an interesting part that I want to bring up, because a lot of what happens in disasters is you want to do real-time decision-making, and having access to historical data to put on top of it can be very useful. Mostly that's used for risk analysis and is separate right now. So here's an example of satellite imagery. So things are moving very fast in how satellite imagery can be processed. This is an example of a company, Tomnod, that spoke in my Tulane class, and what they're doing is crowdsourcing the processing of satellite imagery. So there's pushing the satellites to the right place, there's having them take the right pictures, and then they're finding the right things in the pictures. These are all things that our time delays in getting new satellite information, and they're all getting shortened. So more satellite imagery will be available faster, and you'll be able to find what you need from it quicker. Ground reports. These are two examples of very different types of ground reports, and this is, of course, in addition to all of the Twitter feeds, and we'll talk about social media in a little bit. But here are examples where basically non-professionals are providing information to different levels of authentication, but seem to be improving in their quality. So there's Google Person Finder. So this is someone saying, I am missing this person, or I am this person. And on the right-hand side, this is CNN's iReport, and what they're asking people to do is to become a reporter and post their own photographs of things they see on the ground. So these are two data sources that have not been available, that are becoming more available, and the power really is big data, right? These aren't really big yet, but the idea is that more data is going to become available, and that can be used in situational awareness. Historic data, this is an example of floodplains. One of the challenges is making sure that geospatial data, such as historic data, for predictable events like earthquakes, floods, not necessarily things like a tornado or a hurricane. Sometimes that is less predictable, and so this historic data is less valuable. But telling you, for example, where you're likely to flood, these are data that aren't necessarily being incorporated in real-time decision-making now, and of course, as more data are generated and compiled and made more useful, there's great potential for coordination around these data. So we have all these data, and more of it is becoming available. Why? What are the challenges to coordination? So they run the gamut, really, and there's some great software programs. Palantir does great stuff around data analysis, WebEOC. There are companies such as Intrapoint, which I've worked with before. Depictions of HANA Eden. These are all common operating pictures that have other layers of connectivity with them. That are addressing these challenges, but what we're going to get at is that there are some really basic problems that are across a wide range of issues that mean that in a natural disaster, things aren't as smooth as you'd hope. So data access. So imagine that you have a data stream and you're a police officer, and then there's a fire department that wants to have access to that data. There are all sorts of challenges to that. So there's just what's your policy? Technology challenges about, are you using the same software? Are you using the same radio station frequencies to talk? There's security challenges when you start opening up your data. What level of responsibility in the other organization are you going to let use your data? And then a really basic problem is that a lot of the software programs that are being used have really low user friendliness. And one example is a federal program in the United States where all of the data is shared via PDF. So they make official reports, and the data is shared via PDF. So it's very difficult to search, very difficult to find things. So really basic challenges to just getting a hold of the data is one issue. And there are lots of technological challenges that are similar to a lot of the big data challenges that you hear in other use cases. So simply data mining for data in disasters. This use case turns out to be really interesting because meanings of words change in real time. So for example, in Hurricane Sandy, the word sandy all of a sudden is not an adjective to describe a beach, like a sandy beach. It became the name of a hurricane. And so these changes in word meanings happen very quickly and are challenging to data mining for things like big data processing on things like Twitter. Simply sense making. So how do you get all the information together in the picture that you need and get the right people to look at it in order to put everything in context and make some sense of it? And accuracy is a big one that we're going to talk about. Accuracy encompasses both the accuracy of the data and the organization's level of comfort with saying something is accurate or not. And of course, it may make a difference whether you're making a certain decision or not. You may have to be 100% certain if you're going to deploy troops, but you may only need to be 5% certain if it's something that you want to just take a little bit of look at, a deeper look at. And then there are lots of data use challenges around policies, training, culture, and cost of getting professional responders to get involved with data at a deeper level. So data access, we did a survey of local disaster managers in the Bay Area, and we asked them how many software programs do you use when you do your job? And one of them used 40 programs. So she had to remember 40 passwords. They changed every 90 days, and she would need different ones for different events. So that's a real challenge just because none of these programs are talking to each other. There are lots of policies that limit your access to authenticated information. People do not want to share slightly authenticated or non-authenticated information to the public unless it's been fully vetted. And of course, we want to use user friendliness. Let me jump through here. Filtering. This is a very messy screenshot. These are tweets from a disaster. Many years ago, the San Bruno fire, they thought it was another 9/11 terrorist attack just on the West Coast for the first little bit, and then that was quickly dispelled. It was just a fire. But as you kind of look through here, you can get a sense of how difficult it is to pull out useful information. People are swearing, they're providing useful information, they're commenting, they're talking about a specific person. So this just gives you an idea of the type of information that you have to look through. I think it's interesting for people to actually look at the data to understand the challenges. And then accuracy. The image on the right is a picture of a weather phenomenon that happened in Florida many years ago, and it was circulated for a while around Hurricane Sandy, and many people believed that this was a picture of what was going on in Hurricane Sandy until that was quickly dispelled. But the problem is that if you're an agency trying to make decisions, can you trust social media? The concern about inaccurate information maliciously being posted is very real for a lot of these responders. And then policy, culture, and training. So this idea that you need a social media policy has become very real for many small organizations, especially when they've been bitten by social media. For example, I heard a story about an emergency responder who got fired because someone had tweeted a picture of a person in a building that was being evacuated, and they asked the emergency manager about this person in a press conference, and he had no idea because he hadn't been following social media. So for good reason, small agencies who don't have a lot of budget are concerned about social media backfiring on them, and they're also challenged by the huge public pressure to engage. And the two pictures in the middle are a really interesting example of Los Angeles Fire Department's policy around social media. Basically, they're still forming policies, but what they decided to do is have one channel on Twitter that talks about emergency information about local fires, and then the other channel on the right-hand side is really a public relations channel. You can chat with firefighters. You can know them by name. You can engage them in a conversation. And so they've had to allocate firefighters and time. And what you find is that social media in particular and data processing, it costs budget. Even though Facebook is free, it takes a lot of time to manage it properly, and doing it wrong can be costly for your organization. So, and on the right-hand side, this is just an infographic about training, and I think it was supposed to show that training is simple, but because you can't read it, it's clearly not simple. So anyway, moving on, current coordination mechanisms. We're going to talk about coordination among official response, mostly common operating pictures, and then some attempts at dealing with engaging in data exchange with the public. I'm going to move through these pretty quickly. I'm happy to provide more information later. So on the left-hand side is a 2007 picture of California wildfires. So that's kind of what was going on in 2007. And then on the right-hand side is the Hurricane Sandy map. And these are examples of ways that information has been shared. On the left-hand side is a PDF. It's static. It doesn't move. And on the right-hand side is a dynamic web page. There's still a lot of challenges with pulling that information on the right-hand side, but these are kind of the ways things have been moving. One of the most widely used PDFs, certainly most widely circulated PDFs for sharing data is this one of the New York City subway. And what it is it's an interactive PDF that you can turn on and off layers. So the left-hand bar represents layers of different information that you can kind of click on and off. And so this is kind of a standalone GIS vision, and the value of it is that you don't have to have uncommon software in order to use it. PDFs and Adobe are very common, and so it's a nice way to share information, but it has a large number of limitations, and one, it's not real time. So moving on to how people are dealing with social media, American Red Cross has been working with Radian 6, division of Salesforce, to look at analysis of social media, and they've been making great advances recently. I wanted to show you this because one of the challenges that they've been having early on is that everything is keyword-based, and it gives you a very rough granularity. And it's not really clear that this level of rough granularity can be particularly helpful. And so even though you analyze the data on like a Twitter feed, how you get actionable data out there is still a real challenge. And then this is an example of FEMA's most recent website, beginning to interact a little bit more with the public, and here's an example of data exchange. This is a Twitter chat that FEMA had set up, a live Twitter chat to exchange information. This is, again, moving forward on the policy development, responding to the public pressure for exchange of information, and how they're responding to that. And so in summary, coordinated response is one of the many key goals of disaster management. But this is a constant challenge that emergency managers tell me about. Disaster response involves a large number of agencies and actors, and many of them don't talk to each other on a regular basis. Many of them come from very different worlds and have very different expectations. So it's a very big challenge to try and get them all together and to exchange information. There are a lot of recent technological advances that increase data flow, the satellite ground reports, historic data, and all of that. There's going to just become more of it. However, there are some real basic challenges around accessing the data, from sociological, policy, technological, and simply decision-making. There are a lot of other things we could talk about. And then we kind of just briefly talked about some current coordination mechanisms, and the surprise for me is that they're not as complicated, they're not as deep, they're not using particularly developed data analysis mechanisms compared to what's out there, but there are a large number of challenges and reasons why they're not using those. So that's just kind of a brief overview. And I think I'll end there and take some questions.
Awesome. Thank you, Jeannie. So I guess the biggest question that people seem to be asking in the background here is related to some stuff that Ari was talking about, and I'm wondering if you can chime in on it as well, which is the coordination of this stuff across different groups who may not want to or may not legally be able to share data. In times of crisis, Ari was remarking in the chat that we're seeing organizations that would normally share data band together because they have to. They're under attack by state-level attacks and so on. How do you manage the problem of getting these organizations to share data before the crisis is upon them? Rather than, how do you make them realize the urgency and how much they'll wish they were sharing data beforehand?
Well, that's a really good question, and there are some really interesting projects that are working on this. One of them, for example, is Virtual USA, and what it's doing is working with, I think, 8 different states in the Midwest to help them all figure out ahead of time how to share these data and to set up policies. And so what they're doing is they recognize this need to be able to share in times of emergency, and everything gets easier when you can fall back on a prior established plan, because starting anything new in a disaster is tricky and takes time, and it takes away from your other objectives. So what they're doing is they're really working through these questions about how long can you look at my data, who in your organization can access it. And the Virtual USA, just to explain, is it's a web-based system where you can decide that I want my data stream, let's say it's webcams from the highway. I will allow people, what you can say is I will allow people who are fire departments to be able to access those data. And then once you do that, people who are registered in the system after they've been approved can see that, and that allows them real-time access to your data, and it deals with this problem of people working on different front ends and having different software programs that their data have to go through, or different types of data. Now also work within DHS to get everybody on the same standards for data. So as you work across agencies, you find that people call the same thing, different names. They have different nomenclatures, and so standardization is really the way forward to go to make sure that everybody's comfortable understanding what the data are. And so there are a lot of kind of pushes towards that, but it's a challenge just because of the complexity of actors. So these are policy questions that are being moved on, but it's relatively slow.
All right, I'm going to ask you one last quick question. We all watch TV, or many of us do, and we see in these TV shows that and movies, Hollywood has this sense that anybody can just tap into all of this kind of infrastructure and enhance images and look at traffic cams all over the world and so on. How much does the public perception of the level of connectivity and data availability to deal with crisis and conflict and crime affect regulation and legislation and the expectations of what first responders should be able to do?
Yeah, that's a really good question. We went to, I live in California, and there are, several cities and counties here. And when you go and you look at the emergency response, areas, a part of the offices that, of the government offices that are assigned to deal with emergency management, they still have whiteboards, they still have paper maps. The impression that the public has that there's a matrix-like, response is very much in conflict with a lack of budget and a continually chopping of budget for emergency managers. They don't have budget for it, and because they're used so rarely, and people's kind of expectations of risk and how to manage risk are very different from their expectations of how people respond when they're in a disaster. What it does is it makes a lot of challenges, and the social media example is a perfect example of how policy is being moved very fast because people expect that if I post that on Facebook that my house is on fire, that the fire department is reading Facebook to find out that my house is on fire. People are doing that instead of using 911. And that's absolutely not what the firefighters are doing, but they're having to move very fast. And so I think there's a lot of catch-up, and there's kind of a lot of concern, especially on the city and county part, that they would be bitten because of that responding in this way may set up expectations. There are a lot of concerns that engaging in this way can ultimately harm them because the public perception for their expectations of how they're using it are so different from their own reality.
Got it. Thanks. Well, thank you very much for joining us. I'm going to take things to our next speaker now. So Jason is joining us from evidence.com. I met the guys at evidence.com a few years ago, and I thought they would be a very interesting addition to today's conversation, looking at some of the tools that law enforcement is using to try and change how they go about policing. Jason?
Thanks, Alistair. Glad to be here, and glad to share some stories about kind of what we've seen as as an operator within law enforcement. First, a little background on evidence.com before I get going here. Evidence.com is actually a division of Taser International, which is the electrical weapons provider, and that that has given us a huge sort of advantage in getting adoption with regards to data management, which is what evidence.com does within law enforcement. So I just wanted to give that background to set some context. Let's see here. So I want to introduce this idea that software is eating bullets. I like it because it's kind of provocative, but just generally, I want to promote the idea that using software, using technology to reduce conflict, it's a noble mission, and it's something that I don't think has gotten enough attention sort of from the entrepreneurial community. So want to introduce that as an idea, and of course, this comes from the famous quote from Mark Andreessen, where software is eating the world, which is a really interesting idea. I'm sure we've all heard this by now, but that software is disrupting so many industries, using information to change behaviors, to change economic models, et cetera. So here, after 5 years of building technology for law enforcement, at least on the evidence.com side of things, and 20 years generally, we said, all right, how does this apply to us? We work really hard. We believe we're doing things that are really good, and this idea really crystallized how how the larger trends in the technology industry are starting to impact, government, law enforcement, how society operates. So I want to ask the question, how can software affect crime, bullets, violence, and other public safety issues? Because it definitely can. Also want to introduce this use of force model. So agencies have something called the use of force continuum, which is, this is police agencies I'm talking about, where they follow a protocol with how force escalates, starting with officers having a presence. So if an officer is at a sporting event, that is sort of the first step in sort of reducing conflict, sort of controlling a situation. And then depending upon the reactions of, the public or whoever they're dealing with, that can go all the way up to deadly force. For the purposes of this presentation, I want to focus on how technology can keep us at the bottom, right, in the blue and in the green range, not yellow and above, which is where physical violence tends to occur, and ultimately, death if there's lethal force. So the way officers, approach situations is they evaluate, and then they, are allowed to do certain things. And the taser device is part of this use of force continuum. Guns are in there, batons, fists, verbal commands, etc. We obviously want to keep things in the verbal realm as much as possible. So this is important because the root of keeping things at the bottom of this pyramid is around prevention. This is a picture of an on-officer camera that we built. So some people may have heard of this. It kind of got famous with the stop and frisk controversy that was happening in New York last August and September, where a judge ruled that New York PD should use on-officer video. That really raised the spotlight on the power of this technology. And this photo is actually of the chief of Salt Lake City wearing one of our cameras. This is the camera we produce. It mounts alongside the officer's head. This particular mount goes on some Oakley sunglasses, and it has a pretty serious impact. In fact, while Salt Lake City has adopted it, this is actually from last March. So while Google Glass has been in the press a lot, and it's an awesome technology for keeping in touch in real time, we've been building these on-officer cameras, to document the interactions between the public and law enforcement for the past 3 or 4 years, with great success. So Salt Lake City is on the platform. They're using the cameras. Other cities that have adopted this, we just announced, New Orleans, Birmingham, Alabama, Charlotte, North Carolina, Fort Worth, Cook County, which is in the Chicago area, and the list goes on and on. I'm not sure it's well known how quickly these are being adopted, but it's really changing the interactions between law enforcement and the public. So here's some examples of, this is a chart that we created probably 6 or 8 months ago. Some of the data has been updated since then, but agencies will measure the impact on use of force. So how much use of force did we avoid as a result of rolling out a camera, which is kind of a crazy idea that a camera would have an impact on use of force, but agencies that have measured this have noticed a pretty dramatic impact on their interactions with the public. So the two things that have been measured are use of force, which is down anywhere from 90% in some cities and 8% in other cities, depending on how they measured it and depending what their policy was. But it also reduces complaints. So one of the sort of behaviors that documenting an interaction that the police have with the public has is that it raises the accountability of both parties. Well, when you have both parties, sort of more accountable, complaints go down and trust goes up. So with a really simple device, with just a camera, you have this huge impact on the interactions between the public and law enforcement, which, to be honest, when I joined the company in 2008 to help start up Evidence.com, it didn't really even cross my mind that it would have this big of an impact, but it does. So even to the people building this stuff, there's some surprises. And I'm going to next slide here. So more specifically, we did a study with Rialto, California, and Cambridge University, a couple of years ago. They did a study where they deployed our cameras for a year, and every day an officer would go in, they would get a camera or not to try to get a random study, and what they found was a 59% reduction in the use of force, and 87% reduction in citizen complaints. Now, Rialto, California, it's about 50 miles inland of the ocean. Had some issues with crime, had some issues with citizen complaints, et cetera. So the impact here was pretty dramatic, and we're super excited that someone like Cambridge University was willing to do this study with us. So, taking a step back to the original idea of software eating bullets, 59% reduction, use of force means, 59% less baton strikes, less ticks, shots fired, and ultimately fatalities. Like keeping whenever someone knows they're being recorded, they're less likely to misbehave, and the less likely they are to take, their use of force up, the less likely the officer has to react. I mean, it's a pretty simple concept, but has huge implications. So now I want to switch subjects to some of the vendors that are partners that are handling data analytics, data management, et cetera, for law enforcement. I should have had Palantir on here. I apologize for not having them on here. They're obviously a huge player in this space, and have great respect for the work they're doing with Palantir Gotham. But so there's our program, which is evidence.com, which is cloud evidence management. So we talked a little bit before about managing data for agencies, private companies doing that. That's a service that we're providing to law enforcement today. You have Esri, who's one of the oldest mapping providers. They have a lot of services that will put data on a map so you can see all your data in one place. IBM has a product called CopLink, which allows sort of on-premise software sharing between agencies. It's not in the cloud, but agencies will use it to share between agencies to try to have situational awareness sort of in a larger geographic area other than their own city. And then there's some startups in here. So there's a company called Predpol, which is a startup out of Northern California that's doing some predictive policing. They take in data from an agency's RMS system, and for those of you who aren't familiar with how law enforcement manages their data, the RMS system is a records management system. So think of it as like your system of record that all your reports would go into. So when a crime happens, who was in the crime, et cetera. They pull that data in and apply some predictive analytics on it, put it on a map. A startup going after this space. Mark 43, a cloud-based RMS company. RMS is a big problem. I think Jeannie talked about like the user interfaces and all of the sort of problems with law enforcement software or software in government. I mean, it's pretty astonishing how bad some of the interfaces are here. But we're starting to see some innovation, so that's exciting. And then there's a company called Nixle. I mention these because these are interesting companies for people who are interested to go research like what's actually happening in the space, where are people innovating, and what are they doing. Crowdsourced reporting and crime reporting is what Nixle does. So you can report a crime via your mobile phone. Police agencies can push out alerts to mobile devices when there's an issue. Really helps with prevention, et cetera. So moving on, want to talk about the sort of current state of law enforcement IT. And again, like I said, we touched on this, but why has all this critical technology gone unadopted? It's not for lack of desire. This is a slide we use to sort of characterize the world that we live in at evidence.com, because we're focused on multimedia management, audio, video, images, the heavy stuff that can be hard to scale locally. 15, 20 years ago, someone said, wouldn't it be a great idea if we had cameras in our cars? Yeah, that's a great idea. Let's build a system to handle all that data. A few years later, someone says, hey, let's put cameras on the streets that can help us increase the coverage of our policing. Well, now you have another system that manages that data. And that pattern went on and on and on through everything from our own TASER devices, which produce data, to on-officer cameras, to digital crime scene photos, to audio recorders, et cetera, et cetera, et cetera. Tons and tons and tons of sources of information, all going into different systems. And so then you have, sort of at the bottom, you have a whole bunch of people who need it. right? You have the actual officer involved. You have, the chief potentially. You have the district attorney who might be prosecuting the case, et cetera. And they all need different access, different permission sets, and there needs to be one system to do that because it can be kind of a mess otherwise. And it can be very, very difficult to apply any kind of big data analytics if all your data is not in one spot. So, that's something that we're trying to do on the multimedia side is, allow agencies to take all of their, data sources and put them in one spot, working with them to do that, just for basic data management, right? So on the one end, you kind of have Palantir, who's doing lots and lots of super smart analytics, making some decisions that, agencies and other companies wouldn't be able to see themselves. On the other side, there's the sort of, the plumbing, like the IT plumbing that is at these police agencies, which in a lot of ways needs to be redone. And so that's something that we've dedicated the last, few years to doing. We obviously believe the solution to this is us. Whether, I'm obviously biased, but if, at the end of the day, for the public good, this data needs to be consolidated into one system. Whether or not it's us, I hope it's us. I think it will be. But, the important thing is that we increase the efficiency of how agencies manage data. So moving on to another sort of popular subject that we've seen in the news lately is healthcare.gov, right? So this raised the issue of, well, why can't we get there, right? So, the diagrams that I showed is kind of where we are, kind of where we're going. Why haven't we already got there? The real issue is that so many of these government IT projects fail largely because the people who win these contracts to do this work tend to be the best people at managing the procurement process and not necessarily the best vendors to do the work. The procurement processes in government can be pretty intimidating to a lot of startups as well, so it can intimidate innovation. I think that's starting to change. There's definitely a sentiment, at least within law enforcement, that they wanted to change badly, and they're willing to do things, to make it change because they see how much benefit they can get by improving their technology. Here's sort of the state of where we are. This is kind of meant to inspire some of the entrepreneurs out there. I'm a former, entrepreneur, so, always like to speak to that audience. This is where, this is an internal study that we did in terms of where agencies are in terms of considering the cloud. So you have 46% not considering now. You have 16% already using. So you have 38% of the entire market in the next 2 years that's going to move on to this sort of new paradigm of managing information. This should be pretty inspiring to anybody who's building technology. Law enforcement alone, to many people's surprise, is a multi-billion-dollar IT market. So on data analytics, how can we further sort of like reduce conflict between people outside of on-officer cameras, which I'm intimately involved with. Prediction leads to prevention, avoidance. We use the Nixel example. Early warning, pre-notification of consequences. All these concepts are things that are ideas that have been floating around, but no one's really sort of brought a product to market and driven it to adoption. Cop car being present, that exists today. That's an example of what's being done today. An AXON camera, a laser dot from a taser. What a lot of people don't know is actually with our weapons, as soon as the safety goes down on a taser, it puts a laser sight out, at which point most conflicts end before the actual device is fired. So there's lots and lots of examples of how we can use technology to sort of prevent and predict. I talked about PredPol before. I pulled this information off their website. Thought it was interesting. We're still early days on a lot of this stuff, so I don't want to present this like all these studies were done by Cambridge, but we are seeing results with the technology that's being rolled out. So in Los Angeles, they did a test with PredPol. Crimes were down 13% in the 4 months following the rollout of their predictive policing. So they were telling the police officers to go to a location, where crimes were likely to happen, and that, at least according to this data, prevented it from, happening in some cases. Faster response times to crimes means less likelihood of escalation. So if you think about just any human interaction, it doesn't start immediately with a gun pointed at your head. It starts with an argument, then it moves to something more than an argument. Then it might move to lethal force, right? So if we can get officers on scene, if we can get innocent people out of the way quickly, the likelihood of them getting injured goes down. Should a CAD system pre-position patrol officers in anticipation of a crime, right? So Uber for cops. So if you think about, everybody knows Uber. Uber, tells cars where to go in a city to, have the most likelihood of a pickup and reduce, pickup times. There's no reason that won't be applicable to police as well. NIXL, real-time situational awareness. You get alerts. So there's a case study actually that was pretty compelling of the impact of this technology when it's deployed. A senior citizen went out to check the mail and never came back. This is in Chula Vista. Her husband worried about a recent episode, called police. Chula Vista issued the first of 2 alert messages asking folks to keep an eye out for a disoriented elderly woman wearing yellow shorts. The message was sent within a half a mile of her home, so they just geofenced it. 45 minutes later, they sent a follow-up message with a complete description of the woman and a picture, widening the message out to 2.5 miles. Citizen received it. Received the message, saw the woman, allowing Chula Vista PD to bring the woman home safely. So simple stuff, it's, but this stuff has to be used and operationalized. I want to leave some concluding thoughts. We feel like we've been pretty entrepreneurial in this space, and we always like to inspire others to, tackle some of these problems because they're really important to our own safety. But bullets and violence are a last resort. No one wants them, right? Police don't want them. The public doesn't want them. Technology can help with that. So, we need the best technologists in this space to help solve these big problems. They're not easy to solve, but when we do, they have a big impact. Thanks for your time.
All right, thanks, Jason. We have a bunch of questions for you, so if you got a couple of minutes.
Sure.
So what access do the suspects have to your data and analytics? I guess the question on a broader sense is we used to have the right to confront our accuser, and then we got the right to confront the evidence against us. And now it's like, do we have the ability to see the evidence against us using the tools of our accuser? If the police have, for example, facial recognition or license plates to augment their data, how does the accused get access to that data to sort of level the playing field in court? How does evidence deal with that?
Yeah, so when, at the end of the day, the evidence collected by law enforcement is property of the taxpayer, right? It's accessible through the Freedom of Information Act. The only exception to that, there's probably a couple others, but the most common exception to that is when there's an active case. So, with respect to a court case, a defense attorney would ask the prosecution for all the information that's going to be used against the suspect.
Does that include the tools that the police have? So, for example, would the defense attorney be able, and then this may not happen today, but it seems like the defense attorney should say, I'd like access to all of the information about all the people who were, whose license plates appear in the video. Who decides whether that's something that the defense has access to versus they're sort of overreaching and that stuff's not relevant? Someone's got to decide you're not going to give them access to information that would be violating a third-party bystander's private life,
Yeah, so I'm not, I don't have a really detailed answer to that question. The general answer is that there's a discussion had over what's relevant. These issues have existed ever since we've been collecting data since the beginning of time, right? If you took a photograph in 1972 and there were 20 cars in the photograph, you would have the same issue and the same discussion. I'm not familiar with the exact sort of legal discourse that happens in each case. I would imagine it's dependent upon the case.
Sure. Okay, one quick question here, and fascinating. Thank you for giving us all this background. What's the correlation to officer injuries with lowered use of force? Do you have any idea of other things that sort of correlate with these reduced use of force incidents? Like
other technologies or?
Just other data. How else? You mentioned that it reduces the number of complaints, the number of uses of force. What other sort of side effects does the documentation of the precinct have on maybe officer health or whatever else?
Yeah, so So use of force is pretty encompassing when it comes to sort of officer health, at least as it pertains to our cameras. But one of the main drivers of adoption of our technology is lowered litigation costs. So another side effect that isn't necessarily officer injury related, because I think that's encompassed with use of force, is that lawsuits and litigation go down dramatically. Law enforcement settles about $2.5 billion a year, in lawsuits, not including legal fees, and a video of the incident can help resolve that without those settlements. So that's actually
$2.5 billion a year.
Yeah, that's the approximation we've seen.
And that's in the U.S. only?
That's in the U.S. Yep.
Wow, fascinating. Okay, thank you so much for joining us. I know we try to get a wide variety of perspectives, and certainly getting this some airtime was great. Our next presenters, Marie and Chris, joined us at Strata in New York. They work for the International Peace Institute, and they're going to talk about waging peace rather than waging war. Marie and Chris?
Thanks so much. It's great to be able to talk to everyone today. As you just said, Chris and I are from the International Peace Institute in New York, where we conduct research and convene events on peace and conflict issues around the world. So we're really coming at this from an international perspective. And one area that this includes in our work is looking at ways to prevent conflict before it breaks out. So whether that's through early warning systems or helping the United Nations, for example, or other actors to find the best way to respond to rising tensions or disputes. So today we're delighted to be able to share some of the ways that big data and new information and communication technologies can be used to predict and to prevent violence and conflict. So first, I'd like to share with you some lessons to keep in mind in leveraging new technologies. And in particular, connectivity to prevent conflict in a number of different settings. And then Chris will share some innovative ways that we're using data science here in New York to map existing conflicts and raise the alarm before new ones break out. So we keep hearing how big data and mobile technologies are the next frontier for creating value in the private sector. But how can they be used to help international actors like the United Nations, governments, and civil society organizations in their efforts to prevent conflict? Well, at IPI, we've been doing some research into the very early stage initiatives that we've seen so far in this area in conjunction with the UN's Development Programme and the US Agency for International Development. And since the private sector is such a vital partner in this area, providing tools and expertise, we think that the lessons we gathered could also be useful for this broader audience. So we produced 5 case studies that address conflict prevention from different perspectives. And I'm delighted that Helena, the author of one of those case studies, is also on the panel with us today. We'll be hearing from her shortly. The cases covered different regions of the world, so Africa, Asia, Latin America, different types of violence, so criminal violence, but also election-related violence, armed conflict, and violent riots, and different political contexts, so restrictive governments and collaborative governments, as well as the gamut of different technological tools, from big data and cell phones to crowdsourcing and social media. So what did we find? Well, we really didn't want to design a sort of grand theory of new technologies and conflict prevention. The diversity and changing nature of the conflict settings that we explored strongly suggests that those seeking to prevent conflict need to adapt their strategies to the context at hand. For example, in a context of entrenched criminal violence, let's say organized crime in Mexico, tools and approaches that allow for user anonymity seem to be critical for incentivizing citizen use of social media and blogs to contribute to prevention efforts. But this kind of approach is unlikely to have the same effect in a situation of election-related violence. So in Kenya, for example, where we did see election-related violence some years ago, it was quite clear that the information could very easily be politicized. And so vetting the information that citizens were giving for prevention efforts was critical to avoid false reporting. So with this in mind, we identified 7 concrete points that together can be taken as a sort of how-to guide for organizations embarking on conflict prevention initiatives that seek to leverage new technologies as they do so. First, new technologies do have the potential to make huge contributions to conflict prevention, but even if we have an amazing new app or revolutionary new software, sometimes the technological tools just won't cut it, and I think it's important to acknowledge that. So, for example, thanks to video and social media, we have extensive knowledge about what's going on in the war in Syria right now. But still, we've seen that the decision to act on this information has remained a very political one and doesn't necessarily come out of Damascus. So even if you crowdsource your hammer, not every problem is a nail. Second, we have to acknowledge that the tool that you use in Cairo might look very different from the tool that you could put to use in remote areas in Sudan. One initiative that encouraged a network of women in rural Kyrgyzstan to use mobile phones to text in information about rising tensions and violence in their communities, it simply didn't work. It turns out that a lot of these were elderly women who did not know how to text, and they didn't want to learn either. So we're still seeing a lot of supply-driven initiatives. You know, I have a new piece of software and I want to use it, rather than demand-driven initiatives, or ones that may not always be appropriate to the context, which means that needs assessments and feasibility studies should be standard practice here, even if we're not talking about the typical business venture or sales strategy. Third, in particular in settings of violence and conflict, it's vital to consider the knock-on effects and negative impacts that specific technologies can have. We know that drug cartels in Mexico are killing bloggers who are raising the alarm about their criminal activities. Restricted governments are also using new technologies to halt information flows or to identify and target members of dissenting groups. So the risks in a setting of violence or conflict are very high, and emphasis on participant safety and a conflict-sensitive approach will remain crucial from the conception of an initiative until long after its completion. Fourth, continual input from the local beneficiaries is also vital throughout. For example, in Sudan, one online crowdsourcing system that sought to monitor and map violence around election time ended up competing with existing local initiatives that were paper-based and had only received a fraction of the early warning messages as a result. On the other hand, initiatives that built on existing civil society initiatives and got their buy-in proved much more promising. And this leads me to the fifth point. Perhaps the most significant innovation created by advances in technology is the empowerment of individuals to participate in conflict prevention initiatives in their own communities and societies. As we've seen, you can have all the information and technology you want, but that doesn't mean there's going to be a response at the international level. But today, citizens can use digital technologies to more easily spread information horizontally at local levels, so that they can get out of harm's way, so they can put pressure on local decision makers who are more likely to respond, and so that they can incentivize positive change in their communities and their societies. So organizations should support the emergence of these horizontal initiatives, providing support to develop local capacity, to improve connectivity among different initiatives, and to help the sharing of best practices. 6, much more work is needed to identify the levels of trust, transparency, and control that individuals, businesses, and governments are willing to accept when it comes to sharing data via digital technologies in the context of violence or conflict. In Kenya, for example, the study showed that suspicion and distrust of national police and security services may have contributed to communities' reluctance to share information for early warning over their mobile phones with the national body that was established for this purpose. Finally, partnerships. There are indications that prevention initiatives that drew on the complementary strengths of international donors, governments, private sector, and civil society proved more effective. You know, as Jeannie was saying earlier, talking about disaster management, coordination really is one of the biggest difficulties in conflict prevention initiatives too. And the need for partnership in the realm of big data is particularly acute, given the array of actors involved in extracting actionable information from the data deluge. Private companies that hold the data, the technical experts or academics who can analyze it, civil society actors who can put it in context, and governments and international bodies that can guide its safe use and incentivize cooperation. So these are our 7 points of a tentative how-to guide for leveraging new technologies for the prevention of violence and conflict. I'll drop the link to the report in the chat in a minute. And I'd just like to say, we're in the very early stages in this field, and in some ways we know much more about how not to do it. But we also have concrete examples of what could really work. And with that, I'll hand it over to Chris.
Thanks, Marie, and thanks for everybody for attending today. So as Marie mentioned, we've sort of been approaching this intersection between technology and international security from two angles. So she just ran you through some of the cases from the field and some of the lessons learned from the field. But we've also been looking at ways to apply data science into what we do on a day-to-day basis, interacting with the multilateral system here in New York. So one of the really stark divides over the last few years is the skills gap between the private sector and the kind of analytics that are available to the private sector and what NGOs and academia, the people that work on some of these social problems, would like to be able to do. And this is especially related to things like crisis management and conflict prevention. So short of the occasional partnerships with groups like Ushahidi or hackathons sponsored by groups like DataKind, who all do awesome work, you're kind of out of luck if you want to engage in data analytics in a long-term or strategic way as an NGO, just because of the skills that are lacking within the organization. So in the private sector, one of the things that kind of comes up is that it becomes harder and harder as we kind of move along, as technology increases, to kind of pull value out of the types of analytics that we're all doing. In the NGO world, that's not really a problem. There's a ton of low-hanging fruit out there, and there just doesn't really exist the skills base within NGOs often to kind of extract the value. And the value doesn't tend to be the sorts of value streams that attract kind of venture capital. So over the last year, ITI has tried to do a tiny bit to fill this gap through what we're calling the Data Lab. And the idea is to create sort of a dual language program that has feet both in the kind of policy worlds and in the technology world. So one of the problems we've seen is that you have this policy and practitioner community that can be really skeptical of technology. And on the other hand, you have a tech community that tends not to have the sorts of soft skills and expertise that come from working on these problem domains and issues year after year. So a kind of useful example is thinking back to when we first started talking about climate change, the policy issue. Back then it was really hard to get the scientific, the advocacy, and the policy folks on the same footing. And so finding this common ground is what the Data Lab is sort of aimed at. And we've been doing this for about a year, and we've gotten a few interesting projects off the ground over the last year, and I'd like to kind of go over some of them with you. One of the problems with the UN is that there are huge amounts of data that are sort of locked away, information that are sort of locked away in kind of unusable formats. I think somebody mentioned, data being stored in kind of PDFs and how difficult it is to kind of do analytics across these, kind of legacy formats. So one of the things that we've done is try to extract, this is part of a bigger problem kind of on creating an information portal for UN peacekeeping. We created a data extraction application in Python and used to strip data on peacekeeping contributions over time out of PDFs and make it available to researchers, policymakers, and the like. And so now we have a structured database of who gave how many peacekeepers to which missions over time, so you can do kind of analysis on peacekeeping contributions over time, which has never existed before. So this allows for really interesting nuanced trend analysis on peacekeeping contributions. So on the screen here is the regional shifts over time of contributions. But it also feeds into parallel lines of research around peacekeeping and conflict and fills in a data gap previously filled by research assistants doing manual data entry into Excel sheets. Another project that I want to talk about is this, we're calling the Machine Learning and Conflict Prediction Project. So at the UN, there's this idea of an early warning system, and it's sort of, kind of always talked about. And the idea is that if you can collect enough actionable intelligence and information in advance of things like conflict or mass atrocities, you can marshal resources to prevent things from escalating. So we've been looking at ways to operationalize things like machine learning as part of an early warning toolkit. Our goals for the first trial I wanted to develop were to test the kind of feasibility of this, kind of test the value added, and to develop sort of a toy model just to kind of test these things. And we were testing against a baseline of simply previously knowing that an area had previously experienced conflict in the 3 years before. So over the last year, we did the first trial run, and we found improvements in accuracy based on both the algorithms that we used, but the methodology used, and also expanding the data over the kind of baseline. We also segregated the most recent data, the 2012 data, and test a kind of incoming homogeneous set of data to see how accurate it was. We mapped the results on the screen up here, kind of a geospatial mapping, and you can see that there's a tendency for overprediction for sure, but it's not geographically random, and so this indicates that there's promise here. So we're hoping to kind of develop this into a usable model going forward over the next year. And hopefully this is just the beginning. So over the next year, we're going to be using data science to research intersections of health and security. We'll be trying to develop better indices of communal vulnerability to conflict, and we'll be looking at ways to use data science to move policymakers to make better decisions. And so I want to close out with some observations. Coming from the NGO world and kind of dealing with these problems. The first is that one of the biggest things that the data science and tech communities can offer is sort of the skills. There are some really great organizations that are already doing work to facilitate this, like DataKine and TechPop. And these types of initiatives are really great for a bunch of reasons. Practically speaking, they're a great way to kind of marshal resources and get innovative projects off the ground relatively quickly. But I think more importantly, to build these sort of bridges between groups that may not have a great history of speaking the same language. And more selfishly, they kind of help people like me who are interested in figuring out the kind of how-tos and technical details by pointing us in the right direction in terms of kind of skills and methodologies. Well, these partnerships need to be two-way, and I think that the NGO has a lot to offer back. Practitioners have a lot of experience and kind of contextual knowledge that can be really useful to help companies that want to develop effective corporate social responsibility strategies. And I think that these places that we're kind of working in, while they're sort of relatively unstable now, will be really useful or really, huge market segments kind of in the not-so-distant future. So engagement with these issues today offers a jumpstart in expanding, perspectives and reaching new audiences tomorrow. So, to kind of close, I think that, effective communications between, conflict prevention practitioners, technologists, and effective communities can really build bridges and break down the silos in which we're all trapped. So thanks.
Awesome. Thank you, guys. Fascinating, and thank you for speaking up there. It was a little hard to hear you right at the beginning. So do you guys have, we've seen the mapping and the kind of data that you're collecting here. Can you give me concrete examples of do you have any control groups of when you are and are not mapping this data? How does it get into the hands of an organization? Have there been any big sort of, we were able to save this many people or stop the displacement of these victims of a conflict? Give me what are the concrete results of sharing this kind of data with people?
Right now, we're really, especially with machine learning stuff, it's really kind of early days. So the last year was really about testing the feasibility of a system and trying to kind of develop a toy model and see if it was actually worthwhile pursuing. So over the next year, we're going to try to develop an actual kind of actionable application that could be used by practitioners across the street. So there really isn't any kind of, we're using data from 1997 to 2012, so it's all kind of prior data. But over the next year, it's about kind of integrating incoming streams of real-time data and trying to develop an interface that can actually be used by practitioners.
Cool. All right. Thank you very much for sharing this with us. Great to hear it and get it out to this audience. If you want to jump in on the chat room, there's lots of conversation going on there. Our next speaker, Helena, is actually not with Interpeace. She's part of the Standby Task Force. She's the organizer for How to Build Peace and a whole bunch of other interesting things, and she's going to continue thinking about conflict early warning. Helena.
Thanks very much for having me, and thanks for the introduction. So it was great to go right after IPI, since a lot of what they're saying I'm going to also be revisiting, but perhaps with some concrete examples from some work that I've been doing. I spend most of my time working as a consultant to international NGOs and to the UN working with people in conflict contexts and often helping them to find ways to use technology to enhance their peace-building operations. And so I spend basically a lot of time talking to community-level peace builders and asking them what tools they need in order to respond better to conflicts. So what is it that what information is it that they need to do their work better? And why do we need to warn them about conflicts, or what actionable data do they need in order to respond to a conflict? So, I think initially when you first start speaking to people who are working very much on the ground in a conflict context, there's this sort of, what's this whole early warning thing that you're talking about? And what are the assumptions that are behind thinking that we can warn people about conflicts? And I think that the main thing is that we think, if you're willing to engage in early warning, you're saying that there are reasons that explain a conflict. And that's what we need to look for. So in other words, conflict is not idiosyncratic. We may not be able to perfectly predict conflict. Our predictions may be imperfect, but we can predict it with some probability greater than chance. So there's a reason that we want to engage in what the reasons are behind a conflict. We want to look for patterns. We want to look at the past trends for conflicts. We want to look at the logic within a conflict system, because we think there is some logic within a conflict system, and we want to find risk factors. This doesn't mean that conflict early warning prediction needs to always be quantitative or always involve statistical modeling. It might be that we're just talking about systematic and organized qualitative data collection. Basically what we're trying to do is we're trying to provide people who are working in a conflict context with tools that will help sharpen their understanding of the past, and also articulate their intuitions about the future. So, not just looking at quantitative statistical models, but also qualitative data and intuition. So with those assumptions, when I first started speaking to community-level peace builders, I would often get a response like this. Yes, your system says that this is the kind of conflict we can expect, and we kind of knew that already. You're not really telling us anything that we didn't know already. I found that a lot of community-level peace builders were dismissing early warning systems, and particularly data-driven early warning systems, as a lot of work to tell them something that they already knew. And maybe initially that might seem like a sort of a gut reaction of people who don't want to take on more work, who are already working under very difficult circumstances. But there's also some evidence to back that up. Many predictive conflict early warning models are only marginally better at predicting a conflict, marginally more effective than rules of thumb used by community peace builders. And there's some research that shows that this is true. So I started to wonder, what is it that we're doing wrong? Maybe we need to think about early warning in a different way. So it strikes me that most early warning models focus on identifying indicators that have a strong predictive power over conflict incidents. In other words, we're concerned mostly with structural or ecological conditions that make a conflict incident more likely. That's what most of the models look at. What most of the peace builders that I was talking to were interested in was understanding the motivations that drive people to engage in violence. They wanted to do that in more robust and systematic ways. They wanted to understand how is it that people structure their choices to enter violence. And that's a much more qualitative, maybe much more intuitive set of data, but it's also something that can be done with data. And the reason that they were interested more on motivations and on relationships that drive decisions to engage in violence was not just because they thought these were good predictors of conflict, but also because they provided a better guide to action on peace building. So they weren't just receiving information as a warning to conflict. It was also, in a way, a recommendation on how to respond. So what I want to spend most of the time talking to you about is 3 examples of projects that are using data to work more on the side of conflict early warning that looks at motivations, that looks at relationships, that looks not just at conflict incidents and structural and ecological factors, but also at the other things that are going on in a conflict. Of these 3 examples, I just want to be really clear. I have been a little bit involved on the first one, which is UNDP's exploratory work with the GDELT data set that I'll talk to you about in a minute. I have not at all been involved on the Carter Center's work in Syria with social media. I just think it's a phenomenal piece of work that they're doing, and I just want to use it as an example of what things could be done with social media in the future by other organizations. And the third example with UNDP in Cyprus is one that I've been following for a long time and that I've been advising on for a while. So the first example is this piece of work that UNDP is doing using the Global Data on Events, Location and Tone data set. And this is a data set which is a cross-section of all major and local and hyperlocal news sources that are available online, and it's coded by type of event, by location, and then by a number of scales that relate to the tone of the news piece, and it's updated on a daily basis. The data set is available for free online. It's curated by somebody called Kalev Litaru, who makes it available for anybody to use. And I like the way that Kalev Litaru describes the GDOL dataset. He calls it a passive poll of press across the world, which is quite a good way of understanding what it is quickly. So UNDP wanted to take a look at how this daily updated dataset of news events could help inform UNDP country offices in conflict context and help them to make better decisions when things were becoming difficult in a particular context. And so they've done two case studies, one on Tunisia during the Arab Spring and another one of Georgia. And I'm just going to talk about the Tunisia one. So what they've done is they looked at the GDOL data set for a period of time around the Arab Spring, around the transition, and looked at the types of events that were occurring, how the tone was changing, and what different actors were saying on news media. The graph that I'm showing on this slide is a graph that looks at the Goldstein score over a period of time. The Goldstein score is a score which the GDOL dataset uses to rank the severity of an event. And so what the graph shows, perhaps a little bit difficult to read because it's such a long period, is it shows the downward trend that there was in the lead up to the transition, and how the most significant drop in tone happened basically right up around the time of Ben Ali's departure. So essentially, one thing that's interesting is one of the responses you might have to this is say, well, surely the UNDP country office knew about this already. People in the country knew that the tone was getting worse in the country. Is this really new information for them? But what is interesting is that it puts it in context, because it shows that it was the biggest drop in tone in that period. It also demonstrates that what a country office that might be really in the context and not being able to really tell whether this is really worse than last week can say, no, really, this is a significant drop, and we need to start getting worried now because something is happening. So, this is kind of that was just one example of one of the outputs of the analysis of the Tunisia data. More generally, the study also did some preliminary analysis on who was saying what and to whom it was addressed. So who were the actors who were talking based on this news data? For example, one of the things that came out of that analysis was looking at the role of unions in the lead up to Ben Ali's departure and right after. And there had been different theories about when unions had really become an important force in the transition movement. And this data provides some insights into that, basically saying it looks like they were actually involved before Ben Ali's departure. So one of the things, this is again very preliminary, and it's still, I think UNDP is still asking the question, what really can a country office do with this data other than have it in context and provide additional context information? One thing that is really interesting is to start thinking about whether this type of data can inform the country office of who they should speak to when things start to become difficult. And this is where this analysis around the role of actors is quite interesting. In peacebuilding, we often think of conflicts as a system of influencers with dividers and connectors. And the reason to think about it in that way is to identify what the leverage points for intervention in a conflict are. And so the question that UNDP is now asking is, can we use the GDEL dataset to help country offices make better decisions in that kind of context? Okay, example number 2. So this is the great work of the Carter Center on analyzing the Syria conflict by curating social media data. There's a team at the Carter Center that has been basically curating a database of YouTube videos of declarations by Syrian armed groups and various other bits that are put on YouTube by Syrian armed groups. There is a lot of material that different Syrian armed groups are putting up on YouTube, so they have a lot to work with. And each video is watched by an analyst and is then tagged according to a very comprehensive list of categories. And then they then use network analysis to look at how the different groups relate to each other based on this data on YouTube. So what I'm showing here is the armed groups in Aleppo Governorate as of January 2013. And I won't go too much into the context, but basically this is in red and blue are the two main players in Aleppo Governorate are being shown. One is the Military Council of Aleppo, and the other one is Liwa al-Tawhid. And what is interesting about this graphic is that it shows that there's actually very little relationship between the two groups except for the two centers, right? But the smaller groups that pledge allegiance to the military council are not also pledging allegiance to Liwa al-Tawhid and vice versa. So that's just one example of the type of analysis that they're doing. But more generally, their network analysis looks not just at YouTube but also at Twitter. So what they do is they use the YouTube analysis to identify the armed groups, and then through that they find the Twitter accounts of the main players that they're interested in looking at, and then they look at who those people have a strong relationship with on Twitter. One of the interesting things that has come out of their Twitter analysis is that they're able to deduce where funding and alliances are coming from. In conversation with some of the people working on this in the Carter Center, they were saying, when people say perhaps the opposition should be funded, that statement doesn't really make much sense in a system which evidently has so much fluidity and so many different smaller players. So I think the takeaway for me from this Carter Center work, which is really exciting, is how feasible is it for other organizations, and I'm thinking mainly of NGOs and the UN, since that's the world I work in, to do this kind of social media curation and analysis to get a better understanding of a conflict context. And then final example is this work of UNDP and SEED, which is a Cypriot think tank, on a platform called SCORE, the Social Cohesion and Reconciliation Index. And SCORE is a very comprehensive perception survey, which SEED has delivered in Cyprus. It basically looks at a number of indicators of social cohesion and reconciliation, and it maps all of them, and it establishes the relationship between different indicators of social cohesion and reconciliation. And it's some of the the findings that are coming out. This is still not finalized, but some of the findings that are coming out are that the drivers of coexistence are different in between the Greek Cypriot and the Turkish Cypriot community. That they're also different for women and different for different generations. And this kind of information is going to help inform how peacebuilding activities should be targeted in Cyprus by some of the peacebuilding actors. So again, for me, the main takeaway from this kind of approach to using data for early warning is to think about how perception surveys can apply in different contexts, and whether the kind of model that UNDP and SEED are using has validity beyond the Cyprus context. And they're certainly interested in expanding it to other contexts. They think the model can be used in other places, and I think it'll be a very interesting development for data-driven conflict early warning. And so finally, to close, I just wanted to share with you 3 risks, some of which were actually already covered in different words by the previous presentation, some of the risks of using data in a conflict context. The first one has to do with endogeneity. I probably don't need to explain this, but evidently as violence increases, the amount of data available about a place will probably go down, amongst other things, because a reduction in data is part of what you're measuring. You're measuring a conflict which has that effect. This is certainly something to watch out for anybody using the GDELT data set. It could be that a drop in news does not mean that there's something less to watch out for, but simply that people can't get news out of a particular place. The second issue to watch out for is one of data availability. The Carter Center is able to do the work they do because they're looking at Syria. You might be able to do something similar in Egypt, but Egypt and Syria are not the Central African Republic and South Sudan, both of which have ongoing conflicts at the moment, and neither of which are particularly rich in terms of social media data. Looking at whether the data availability makes it relevant is very important. And then finally, I think there's a very important issue of ethics, which was touched upon before. I think we think about this particularly in the Cyprus context, in terms of how the data analysis of the kind of data you're collecting becomes part of the conflict dynamic. So how are you introducing, by sharing findings about a conflict dynamic, how are you introducing a new dynamic into a conflict? And that's certainly something to watch out for. Thanks very much for your time.
Awesome. Thank you, Elena. That was great. A couple of quick questions for you. Mikhail asked us, is the usage of a particular set of web services by conflicting parties related to the problem of conflict dynamics? Can you talk about how different people getting things by different tools through different lenses may change the conflict somehow?
I mean, I think I know what this is getting at. I mean, I think I'm not sure whether this is what comes to mind for me, but it's certainly true that access to certain web services is restricted for some players in a conflict and not for others, particularly when you have a very powerful government and an opposition that is not so powerful. So, if we think about places like Sudan, also like Syria, evidently, it's very easy for a government to block access to certain web services and therefore control the internet space to a large extent. And so I think, I didn't address this on here, but absolutely that is part of the conflict dynamic. I think that's especially true somewhere like Syria, where the internet is being used so much to structure the conflict dialogue, right? And you have the Syrian Electronic Army that is making important statements in terms of who has access to what web services.
Interesting. So, I mean, we come to rely on these tools for communicating information which eventually feed the data. There's an interesting feedback loop here when people are trying to intentionally misinform the management systems. One last quick question. How do you leverage cultural motivations behind conflict, particularly if political correctness and diversity agendas actively work to exclude such motivators from the equation? I guess getting at, there's a certain amount of censorship going on of what's tolerant within a particular political community that may skew the data as well.
Yeah, I mean, I think that's, again, a very important point. I think my counterpoint to it is absolutely, cultural motivations and self-censorship are important biases to keep in mind when we're looking at this kind of data. But at the same time, the fact that is the way that the dialogue is being structured publicly is interesting in itself, right? So the fact that you have people who feel that certain political correctness is necessary and are therefore not allowing a particular part of a dialogue to come out, or a particular part of a dispute to come out on online media, is itself part of the conflict. And so identifying the lack of certain views on the online space when you know that they exist elsewhere can be part of understanding and unpacking how a conflict is unfolding.
Great. Yeah, it's interesting. It's sort of a game theory of both parties trying to figure out where truth is based on all that censorship, and the fact that they are censoring tells you something itself. Thank you so much for spending some time with us. I'm going to bring things over to Linus Bengtsson, who is going to talk to us about mobile phone data and how we can use that stuff to understand population displacement after disasters. Linus.
Thanks a lot. I'm sitting in Ouagadougou in Burkina Faso. Do you hear me? Is the line okay?
We can hear you.
Yeah. Okay. Great. So I don't have access to the internet, so somebody needs to advance the slide. Okay. So my name is Linus Bengtsson. I'm a medical doctor and researcher at the Flowminder Foundation, which is based in Stockholm. And I'm also a researcher at the Karolinska Institute in Stockholm, which is a large medical university. Next slide. So now this is slide flowminder.org, a webpage. So flowminder.org is a non-profit foundation, and we're mostly an academic unit. We do method development on how to use mobile operated data for various purposes applied to global public health, so health issues and disaster emergency issues in low and middle income countries. Next slide. So this is just to acknowledge our co-workers and collaborators. So there's a large academic network behind what we are doing. So population movements after disaster. Next slide. This is there are a lot of applications of operated data, but so I'm going to focus on specifically on this because this is the area where we've done most work. And there are extremely large population movements after most big disasters, and they can be sort of trickling, going on during a long time, and in the end being very large, or they can be super fast, as in flooding disasters. And next slide, 2008, 2010 global figures. So there's been work done on aggregating or summarizing the displacement after natural disasters, and actually it's a much bigger problem than most people realize. So during 2008 and 2010, we had 86 disasters with more than 100,000 persons displaced, and these are of course rough estimates. And every second month, every third month, we have a huge disaster displacing more than 100,000 people. And of course, these are not regularly spread out, but there's a lot of things happening especially in the monsoon period. And this actually doesn't include droughts and conflicts. These numbers. So next slide. So now there should be a map of Haiti. So our work really started after the Haiti earthquake, and I think most of you remember it was a very strong quake close to Port-au-Prince in very densely populated area. And you had the same problem here. People were moving out of Port-au-Prince, but very little was known about where they were moving and how many people were moving. Next slide. So basically we had this generic problem that arises in most major disasters, to get the right resources to the right people at the right time. And to understand where people have been are moving, are distributed, and how they are moving and how they are moving back. The previous methods have basically been what's following slide. It's sort of counting people when as they are moving. So counting buses or people walking in a certain direction, and which during the conditions after a disaster obviously is extremely unreliable. You can register people when they reach camps, but camps are set up quite late, and most people, they actually don't go to camps. If they flee, they go to somebody they know and live with, or some kind of host families. And also you can use satellite and aerial images, but what you see is shelters, and you don't see people. and as I said, most people don't live in shelters, but with host families. So there really hasn't been any good methodology. Next slide, please. So we started up a collaboration with the largest operator in Haiti after the earthquake, Digicel, and this is their high-Q after the disaster. And it looks terrible, but the building actually stood up really well, and the servers were all functional. Next slide. So after a lot of discussions on the legal contract side, we ended up analyzing about 1.9 million SIM cards as they moved around Haiti, and all the data that we received were in anonymized format. And the data that is there is basically what is registered is the mobile phone tower that is closest to the user when he or she initiates the call. So we don't know exactly where the user are, but you can follow the user from tower to tower. Next slide. So during 2010, we spent most of that year to disseminate the analysis on how people are moving out and moving back, and also during the big cholera outbreak that happened later during the year, we could very rapidly disseminate the analysis how people were moving to identify areas at potentially increased risk of new outbreaks. Next slide. So this is just an example to show the one simple but very useful visualization of where people went. So here the map shows the number of people in different areas that were in Port-au-Prince during the earthquake, and that were in another place, in the place designated on the map three weeks later, under the assumption that the mobile phones are representative for the population movement, and I'll come back to that. Next slide, please. So now you should see a graph. So what this would show here is the number of SIM cards, and that's the estimated. So the change in the number of SIM cards in Port-au-Prince, and if we think that is representative of the population, we then have a picture of the changes in the population in Port-au-Prince. And what you see in the left part is a stable level in December before the earthquake, and then there was Christmas and New Year, and a lot of people left the city to celebrate. And actually, not everybody had returned at the time of the earthquake in the beginning of January, and then you got, after the earthquake, a very rapid outflow during that month, and then a gradual return of the number of mobile phone users in the city. And the sort of sawtooth pattern you see here is a seven-day cyclical pattern, so it's commuting movements in and out of the city during the weekend. Next slide, please. So we've done quite a lot of academic work after this. In this article, we look at the correlation between so we can move on to the next slide first, the graph. So here you see our mobile phone estimates of where people were moving, and the National Civil Protection Agency figures, and there is very little correlation between the two. And we have quite little time, so I won't have time to describe it exactly, but feel free to download the paper. And next slide. What we do here is a very similar analysis, but on data from UNFPA that was collected 7 months after the earthquake, and where UNFPA asked in a random household survey where did you go? Did you leave the city, and where did you go? So we see that the mobile phone analysis, we have two different versions in red and green, have a very much better correlation to the UNFPA data, which is in beige here. And let's move on. Okay, so this was just to say that there's been a lot of discussions on the ethical use of this data, and for this specific purpose, there's been a very, very good response from the media and agencies. Slide, please. Predicting disaster-induced movement. So if you're interested, there are papers to download. So we've looked a lot at the normal mobility patterns and the irregularity of people's movement before events. So one PNS paper is from Haiti, and a scientific reports paper from Cote d'Ivoire, where we analyzed the orange data from for Development Challenge, and we can show that people are extremely predictable in their mobility, also in these very volatile contexts. And in the case of the Haiti disaster, we had a very good chance of predicting where people would go after the earthquake based on how they moved before the earthquake. And one important predictor were where they spent Christmas. So the interpretation is that people move to places where they have their social bonds, their social networks, and thus we can, if we can understand those social networks, we can probably predict where they will go, and then we have a completely new set of tools for preparing disaster response. But this has to be validated in many other contexts, of course. Next slide. Just a few words on a big project we're working on now, where we're looking at the cyclone Mahasan that took place in May in Bangladesh. We're in a consortium with operators and the United Nations University, among others, and Bangladeshi ministries to understand how people are moving. Next slide, overview, I should say. So this was a big cyclone that hit in May, affecting 1.3 million people, and we're looking then at we're looking at data that was from 1.5 months before the cyclone to 1.5 months after the cyclone. And next slide. So what we know from needs assessment surveys and how different household surveys that was done after the disaster is that there was a lot of damages to rice fields and homesteads, and we also see that people reported a lot lower incomes after the event. 1 month after, they had reduced their incomes substantially. And this is I took this picture from an old man's plot, and one of his big trees had fallen down, which was a sad thing for him. Next slide. Study area. So this is just to say we're looking at the cyclone-affected area in the red here, and we're also looking at the second biggest city in Bangladesh, Chittagong, in the east, and we know there's a lot of migratory movement between these, so it's a likely location for migrant labor to move when okay, next slide. Challenges. So this was just an overview of what we've done and what we're doing now in this field. There's a lot of good potential in getting much better data on population mobility and population distributions after disasters based on this. But there's also a lot of uncertainties and things we don't know yet. The most important thing is the representativeness of the data, and the most important vulnerable groups in emergencies is the poorest, the children under 5, and women that are primarily lactating and pregnant women, and the elderly. And many of these, children obviously and many of the elderly, they don't have phones at all. Others have phones to much less extent than others. And some people have multiple SIM cards, or it's very common to have multiple SIM cards in low and middle income countries. And so who are we really following? And we know that many women will be following other people who have phones. So it's they may actually be represented in the data, but and they seem to be in Haiti. This needs a lot of tedious research to understand how this works, and we're working on field surveys to try to understand what the data represents in different contexts. And I think where we can get is that we learn what type of stratified samples we can take from the mobile phone data to not overrepresent the rich and underrepresent the poor, but to weigh them equally or make the sample much more representative. Next slide. Challenges, number 2. So there's another set of issues of really understanding what these dots means, and it's something that I think most people in this audience is well accustomed to. It's not very difficult to just follow the dots on the map, but what do the dots mean? And I mentioned before that we know that incomes in this cyclone area in Bangladesh decreased a lot, but when traveling around there, we also understood that this was actually right after the harvest and the start of the lean season, when incomes go down naturally. So there's a lot of migrant labor going back and forth. There's farming seasons, and you really need to understand what is just a cyclical event and what is an event-driven change. You have issues, of course, with radio coverage and blackouts, and then there's in disaster that's a big issue of where people carry the phone. So in Haiti, if a person puts the phone on the table and then runs out when the earthquake strikes, that's going to give one picture. If the person has the phone on them and then runs out, that's going to give another picture. So there's a lot of this kind of tedious work that needs to be done. And of course, there's a big set of legal and ethical issues. The data is extremely sensitive for operators, primarily from a commercial point of view, but of course also from a personal integrity point of view. There are legal constraints in some countries on what you can do with the data, and a challenge for us sometimes is that the damages if we sign a contract, the damages can be quite, the liabilities can be quite enormous if something would happen. So there's a lot of things to overcome. I think with more research we will be able to establish what kind of aggregated data that can be that is not threatening to commercially and personal integrity wise, and that can still picture important parts of reality and people's mobility. But there's a lot more work that needs to go into that. So with that, I will finish.
All right, thanks, Linus, and thank you so much for joining us from afar with all the technical hurdles. We've definitely got an international group together. A couple of quick questions for you. The first one, I guess, is you talked about data noise. One of the things that's come up in the past in discussions has been about the difference between qualitative and quantitative data. And I heard anecdotally cases where it looked like a population of a certain region in Haiti had stopped moving, and they thought that was because of an outbreak of a disease, and in fact it was because the bridge was washed out and they couldn't move. How do you balance the quantitative data that you're gathering here with qualitative on-the-ground data to sort of check out these conclusions?
Yeah, that's the key issue. So we always go to the country, and it's essential that you have good links in the country and that you understand the context. And because it's really just dots on a map if you can't contextualize it. So that's key. And I don't think there's any standard answer to that question. You just need to either get there or have really good connections on the ground.
All right, so one more quick question for you then. You talk about, and people in the chat room are talking about how great it would be to get access to all this commercial data, but that's not often available. Are you seeing countries do sort of the equivalent of digital eminent domain, where they're saying, in times of emergency, we're just taking this data, you must give it to us? Where does that stand in terms of being able to invoke an official act that says all this data now belong to us for the duration of an emergency?
The data is, of course, extremely sensitive, so it wouldn't. I haven't heard about any discussion about releasing the raw data, and I think operators would fight furiously not to make that happen. But I think definitely we will see a bigger focus on releasing at least aggregated types of data. So we're working actively with the World Economic Forum, the Gates Foundation, and GSMA, the industry organization for operators, to discuss those issues and how this can be done in a way that safeguards personal integrity. But I think we haven't come, or the world hasn't come very far there, and it's a very difficult issue. Definitely I don't think we will ever see any raw data being released, and I think that wouldn't be right. But as we've been talking about before, I think to specific users that analyze the data, then of course the data can be released, and then the majority can get sort of the curated or the aggregated data.
That's a good answer, and definitely a lot of room for study there. Thank you so much for making the time I know many of you had to deal with international boundaries and technical issues, so thank you all for coming together here. Fascinating conversation. The chat room was one of the more interesting chat rooms I've seen in a while. We covered everything from Russian dashboard cameras catching meteor strikes to data privacy to the rights of phone carriers. So very interesting back channel too. I do want to thank everybody for coming here today, for the great questions, for sticking around for so long. We do have one more online conference coming up February 4th, which is a preview for Strata, the O'Reilly conference on big data, connected computing, and ubiquitous interfaces. And we are going to be looking at some of the things coming up at Strata, which happens in Santa Clara, February 11th to 13th. So thank you all for joining us. Yasmina, over to you to wrap things up.
Perfect. Folks, on behalf of O'Reilly Media, we'd like to say a big thank you to Alistair for organizing today's event, and a big thank you to all of our international speakers and local speakers, and of course to you, our audience. We had people from all over the world attending today, and we thank you so much and hope you benefited from today's event. We did push out a couple things to you all in the group chat, so if you didn't open it, please do. Information about our February 4th online conference, as well as our Strata Santa Clara conference. Folks, we thank you all. This will conclude today's online event. Goodbye, everybody.